guys, Miss Miklos here. And in today's lecture, we are going to be covering rules for exponents. And everything we're going to be talking about in this first lecture is something that you guys actually learned back in Algebra 1. Also, just so you know, there is a note handout available just so you can follow along. So I want to start by just talking about what an exponent actually is. And just a reminder, an exponent means I'm multiplying the base, we call this number right, the base, and this is our exponent. So this is saying we are multiplying the base by itself 6 times. So this would be like x times x times x times x times x times x. So that concept is really going to help us out in knowing all of the rest of our exponent rules. And I would say that the two that get the most confused are B and C here. This first rule, B, we call that the product of powers property. And we call it that because I am multiplying two things that have powers together, and notice that they have the same base. And if we think about it, what this is really telling us to do is x times x times x times x times x times x times x. And looking there, if we counted all of those, we have 7 x's. So what we really did here, obviously it would take a long time if I wrote out every single x. But what we did is we added our exponents together. So this becomes x to the 7th power. So in our product of properties power, when I'm multiplying together two things that have the same base, I add their exponents together. Our second major rule that we talk about is our power of a power property. And I know that when I'm squaring something, that means I'm multiplying this by itself. So this is really like x to the 5th times x to the 5th. And what we just learned about, that means that I really have 5 x's here and 5 x's here. So I end up with 10 x's altogether. And the way that we really do this is I am multiplying these two numbers together. So I get x to the 10th power. So whenever I am actually taking a power to a power, that is when I multiply. When I am multiplying and finding a product of powers, that is when we add. For our fourth one here, I have x to the 5th, y to the 6th squared. And we know that we technically cannot distribute because I do not have multiplication and I do not have an addition sign in between this. So what we're really going to do, we are going to apply this squared to each of these terms. Because technically, this is like we're doing x to the 5th, y to the 6th, times x to the 5th, y to the 6th. So I'm really going to do x to the 5 times 2, y to the 6 times 2, and I would get x to the 10th, y to the 12th. So this is just like using our power of a power property, but it's showing me that if I have multiple things that I'm taking to the power, I need to take everything to whatever this exponent is. Our next one that we're talking about, I like to refer to it as the battle. Yes, we're having a war here. So if we look at this, I have this same base on the numerator and on the denominator. And I know that x to the 5th means I have 5 x's, x squared means I have 2 x's. So I need to determine which exponent is bigger. And I know whichever exponent is bigger, that is the side of the fraction that wins. Okay, so what I mean by that, if I'm comparing 5 and 2, I know that 5 is 3 bigger than 2, so my answer is going to be x cubed. Okay, a lot of you guys have probably learned this before by using subtraction. And the reason why I like the battle better is I think it's easier when we get a bigger number in our denominator. It saves us some time. But really what I did here was subtract these two, and since the numerator was bigger, I knew this 3 went in the numerator. Here's another battling problem, and this time I think that the denominator is bigger. So that means that the denominator is going to win the battle, and I'm going to go ahead and figure out what is bigger, 4 or 8. And I know 8 is 4 bigger than 4 is, so my answer is 1 over x to the 4th. So this is something that is going to save me a step or two if I just go ahead and compare those two numbers, and whoever has the biggest exponent is going to win. Looking at G, you guys might remember from Algebra 1 that we can never have a negative exponent in our answer. And so what we do to make these positive is I'm going to take this on the opposite side of our fraction. Right now it doesn't really look like we have a fraction because it's like this over 1. So this is actually in the numerator. If I want to make it a positive exponent, I need to bring it down into the denominator. So x to the negative 4th is actually equal to 1 over x to the 4th. And that's a big one that we need to always keep our exponents positive. Our next one here, looking at this, when I have a fraction and I'm taking it to a power, I need to take the numerator to the power and take the denominator to the power. So in this case, I would get x cubed over y cubed. And our final rule that I want to talk about before we actually get into problems is our zero power property. I know anything to the 0 power is 1. And we actually talked about that a little bit last chapter when we talked about how I to the 0 power was 1. So that's a quick review of everything that you guys learned back in Algebra 1, and now we're actually going to get into simplifying some problems. So number 1 is telling us to simplify, and we're dealing with numbers here. I have 2 cubed to the 4th power. So in this problem, it looks like I have a power being taken to a power, so I know that I need to multiply those together. So I'm getting 2 to the 3 times 4 power, or 2 to the 12th power, which is 4,096. Now, I just want to point out we could have also done this an alternate way. I could have done my parentheses first, which technically is what we should do, and I would get 2 cubed is 8 to the 4th power, which is also 4,096. So this is a problem that we really could have gone about doing it either way. It doesn't matter. We just need to do whatever is easiest. Number 2, I have the quantity 3/4 to the 2nd power. So I'm going to make this 3 squared over 4 squared because I know I have to take everything in this fraction to the power. 3 squared is 9, 4 squared is 16. I know that I cannot simplify this any further because there's not a common factor in 9 and 16, so that would be my final answer. Number 3 looks confusing because my base is a negative number, but I'm just going to treat this like any time that I am taking a product of powers. So I know it's going to be the quantity -5 to a power, and I need to add these two powers together. So -6 plus 4, and I get the quantity -5 to the -2nd power. I know that I cannot have a negative exponent in my answer, so I have to make this 1 over -5 squared. Notice -5 is still in parentheses here, which makes a difference because when I simplify this further, the quantity -5 squared is 25. So I get 1 over 25 as our answer. So looking at number 4, we are still simplifying, but this time I'm dealing with exponents, so I know I won't have just a number as my answer. So for number 4, there's a few different ways we could go about doing this. We could go ahead and apply our exponent to both the numerator and the denominator first, or we could take care of this negative exponent first. I'm going to go ahead and make this r squared over s to the negative 10th first. So what I did here, even though I don't see an exponent on r, I know it's really like r to the first power. 1 times 2 is 2. Negative 5 times 2 is negative 10. I know this cannot be my final answer because I have a negative exponent. This time, my negative exponent is in the denominator, so in order to make it positive, I have to bring it up into the numerator. So my final answer is r squared s to the 10th. Number 5, there's a lot going on, so I need to rely back on order of operations first. So if I remember PEMDAS, parentheses are first, and there's actually not much I can do inside here. Next comes an exponent, so I need to take all of this to the power. And probably the biggest mistake I see is forgetting to take 7 to that power as well. So I know 7 squared is 49. B to the negative 3rd squared is b to the negative 6th. And then I have times b to the 5th times b. So I know that I have a 49 out in front. And I need to go ahead and since I'm multiplying these 3 terms together that all have the same base, I know I need to add their exponents. And it might help if I just write in a 1 just so I know what that is. When I add negative 6 plus 5 plus 1, I get 0. So I know that anything to the 0 power is 1. So my answer here would just be 49 because 49 times 1 is 49. Number 6, we have our numerator and we have our denominator, and I'm going to work on those separately. So first I'm going to work on the numerator, and since I'm taking powers to a power, that's going to become x squared y to the 4th over x cubed y to the negative 1st power. At this point, if we wanted to, we could battle, but what I'm going to do first, I'm going to move my negative exponents. So I'm going to think of this as x squared y to the 4th times y to the 1st over x cubed, because I want to make sure all my exponents are positive. Now, I need to simplify these x's and simplify these y's. To simplify the x's, I'm going to battle, and my denominator is going to win the battle by 1, because 3 is 1 bigger than 2. In the numerator, since I'm doing a product of powers, I need to add those powers together, and I end up getting y to the 5th power over x. Number 7 is very similar. There's actually not much I can do in the numerator, so I'm going to work in the denominator, and this is going to become r cubed s to the negative 3rd power. Same idea here, where the first thing I'm going to do is make that s to the negative 3rd power positive by raising it up to the numerator. Now when I battle my r's, the denominator is going to win by 2, so it becomes r squared. When I'm dealing with these s's and I'm adding those two exponents together, I get s to the 5th over r squared. Number 8 looks like a really tough problem. However, I just need to take it step by step. Once again, there are 2 ways we could do this. I could simplify everything inside our parentheses first, or I could take everything to the negative 2nd power first. It honestly does not matter the way I go about doing this. Why don't we simplify inside first? So the first thing I'm going to do is move anything that has a negative exponent, so that m to the negative 2nd is going to move down to the denominator and become m squared. Both of these m and n's are going to come up here. So that's going to become m cubed n to the 5th to the negative 2nd power. So I really have 2n to the 10th m cubed over 3m squared to the negative 2nd power, which is 2n to the 10th m over 3 to the negative second power. Now I need to take everything to the negative second power. So that would be 2 to the negative second, n to the negative 20th, m to the negative second, over 3 to the negative second. I know that I need to change these negative exponents right away. Actually, all of them are negative, so I'm moving all of those around. So this is going to become 3 squared over 2 squared n to the 20th m squared. I know that I can simplify these two terms more, so that's going to become 9 over 4n to the 20th m squared. Now, if you guys had done that in a different way, you would get the same exact answer. You would just go about it in a slightly different order. And that is our last example for this lecture. Hopefully this is a good refresher on exponents and how we use them. If you need additional practice on this, I would definitely suggest you do all the suggested problems. Some of you guys probably feel really good on this, so if you have any questions, as always, please let me know.